Have you ever wondered what lies beneath your feet? Not just soil and rock, but something far more extraordinary. What if I told you that deep within our planet, beyond the reach of our deepest mines and drilling operations, there might exist an entire civilization that has thrived in secret for thousands of years? Tonight, we're going to explore one of the most captivating mysteries that has fascinated humanity for centuries. The idea that Earth isn't just a solid ball of rock and molten metal, but something far more complex. Something that might house entire worlds we've never imagined. Before we dive deeper, take a moment to notice where you are right now. You're sitting on what we call the surface of Earth. But that surface is just the thinnest layer of a planet that stretches nearly 8,000 miles to its core. We've barely scratched the surface, literally. The deepest we've ever drilled is about 7.5 miles down, which is less than scratching the paint on a basketball. So what's down there in all that unexplored space? Conventional science tells us it's layers of rock, increasing pressure, and temperatures hot enough to melt steel. But what if that's not the complete picture? What if there are spaces we haven't accounted for? Caverns vast enough to hold cities, ecosystems that exist in perpetual twilight, and perhaps even beings who call these hidden realms home. The concept of a hollow or partially hollow Earth isn't new. It's an idea that has captured imaginations across cultures and centuries, from ancient myths to modern scientific speculation. And while mainstream geology dismisses these theories, there are still unexplained phenomena that make you wonder if we really understand what lies beneath us. Think about this for a moment. We know more about the surface of Mars than we do about the deepest parts of our own oceans. We've mapped distant galaxies with incredible precision, yet vast portions of our planet remain completely unexplored. If there are secrets to be found, the depths of Earth would be the perfect place to hide them. Throughout history, numerous civilizations have spoken of underworld realms. The ancient Greeks described vast caverns where gods and spirits dwelled. Hindu texts tell of elaborate subterranean kingdoms filled with advanced beings. Native American traditions speak of ant people who saved their ancestors by bringing them underground during great cataclysms. Are these just myths and metaphors? Or could they be distant memories of something real? Consider the practical advantages of living underground: protection from surface catastrophes like ice ages, asteroid impacts, or nuclear warfare, stable temperatures year-round, access to geothermal energy, safety from predators and hostile surface dwellers. If you were designing a civilization to last thousands of years, going underground might actually be the smart choice. We've found evidence that ancient peoples were far more capable of underground construction than we once believed. The underground city of Derinkuyu in Turkey descends 18 stories into the earth and could house 20,000 people. It's complete with ventilation systems, storage rooms, stables, and chapels. And that's just what we've discovered so far. Similar underground complexes exist around the world, from the catacombs of Rome to the cave cities of China. But these are just the structures we know about. What if they're connected to something larger? What if these ancient underground cities were just the surface level of a much more extensive network? Modern technology has revealed anomalies that conventional geology struggles to explain. Seismic waves sometimes behave in ways that suggest large hollow spaces deep within the Earth. Gravitational measurements show inconsistencies that could indicate vast caverns. And there are places on our planet where compasses spin wildly and instruments malfunction, as if something below is interfering with our technology. The polar regions are particularly mysterious in this regard. Both the North and South Poles have been associated with strange phenomena for centuries. Early explorers reported compasses failing, unusual weather patterns, and in some cases, glimpses of land where no land should exist. Some theorists suggest that the Earth's magnetic poles might actually be openings to interior realms. Antarctica, in particular, holds secrets that remain locked away. Despite being one of the last frontiers on Earth, much of the continent is off-limits to civilian exploration. International treaties restrict access, officially for environmental protection, but some wonder if there are other reasons for keeping people away. What lies beneath those miles of ice? Recent discoveries of subglacial lakes and river systems show that Antarctica's hidden landscape is far more complex than we imagined. Then, there are the accounts from explorers and military personnel who claim to have encountered things that don't appear in official records. Stories of aircraft that seem to emerge from the ice, of warm oases in frozen wastelands, and of encounters with beings who don't match any known human populations. While most of these accounts are dismissed as hoaxes or misidentifications, the sheer number of similar reports from different sources and time periods is intriguing. But let's think about this from a scientific perspective. If an advanced civilization did exist underground, how would they solve the fundamental challenges of subterranean life? They'd need light sources, which could come from bioluminescent organisms, geothermal energy, or perhaps technologies we haven't developed. They'd need air circulation, which natural cave systems and engineered ventilation could provide. They'd need food, which could come from underground agriculture, mushroom farming, or livestock adapted to cave environments. Water wouldn't be a problem. Underground rivers and aquifers exist throughout the planet. In fact, there's more fresh water underground than in all the surface rivers and lakes combined. And energy. Geothermal power could provide virtually unlimited clean energy for an underground civilization. The more you think about it, the more feasible underground civilization becomes. Not necessarily in one giant hollow space, but in a network of interconnected caverns, some natural, some constructed, spanning continents and connecting through deep tunnel systems. This isn't just fantasy, we're discovering new cave systems all the time. In 2009, explorers found the world's largest cave passage in Vietnam. So massive, it has its own weather systems and could fit a 40-story skyscraper. If caves like that exist near the surface, what might exist deeper down? And consider the life forms we've found in deep caves. Creatures that have evolved in total darkness, developing abilities we're only beginning to understand. If simple organisms can thrive in these environments, what about more complex life forms? What about intelligent life that's had thousands of years to adapt and develop? The implications would be staggering. An underground civilization would have had time to develop technologies we can't imagine, free from the wars and disasters that have repeatedly set back surface civilizations. They might have solved problems we're still struggling with. Clean energy, sustainable agriculture, social harmony. They might possess knowledge that could transform our world. But if such a civilization exists, why haven't they made contact? Perhaps they have, in subtle ways we don't recognize. Perhaps those ancient myths and legends aren't just stories, but garbled accounts of encounters between surface and underground peoples. Perhaps some of the unexplained phenomena we attribute to aliens or supernatural forces actually originate from right here on Earth, just deeper than we've ever looked. Or perhaps they're waiting, watching our surface civilization and deciding whether we're ready for contact. Given our history of warfare, environmental destruction, and social conflict, they might have good reasons to remain hidden. From their perspective, we might seem like children playing with dangerous toys, not yet mature enough to handle advanced knowledge responsibly. There's also the possibility that contact has occurred, but only with select individuals or groups. Throughout history, there have been accounts of people who claim to have visited underground realms and returned with knowledge or warnings. While most dismiss these as fantasies, what if some of them were real? What if there's been a quiet exchange of information happening for centuries, known only to a few? The evidence, while circumstantial, is compelling enough to make you wonder. Unexplained seismic activities that suggest hollow spaces, ancient structures that required engineering knowledge we didn't think early humans possessed, modern discoveries of vast underground ecosystems. military and government secrecy around certain underground installations, strange phenomena at the poles that remain unexplained. And then there are the practical considerations. If you were part of an advanced underground civilization, wouldn't you want to monitor what was happening on the surface? Wouldn't you want early warning systems if surface dwellers started digging too deep or developing technologies that might threaten your hidden world? This could explain some of the UFO sightings and unexplained aerial phenomena that have puzzled investigators for decades. Instead of visitors from other planets, these might be reconnaissance vehicles from other parts of our own planet. Craft designed to operate in the unique conditions between the surface and underground realms, using propulsion systems we haven't developed. The technology required for such craft isn't necessarily beyond our understanding. If an underground civilization had centuries to develop their science without the interruptions of wars and social collapse, they might have solved problems like clean energy and advanced materials science long ago. They might have learned to harness geothermal energy in ways we haven't imagined, or develop materials that can withstand the unique stresses of underground to surface travel. But perhaps the most intriguing aspect of this possibility is what it would mean for our understanding of human history and potential. If there is an advanced civilization living beneath our feet, it would prove that human beings are capable of far more than our surface history suggests. It would mean that somewhere on this planet, people have created a sustainable, advanced society that has lasted for millennia. That's a hopeful thought in a world that often seems chaotic and destructive. It suggests that the problems we face on the surface aren't insurmountable, that human ingenuity and cooperation can create something lasting and beneficial. Even if we never make contact with such a civilization, the mere possibility that it exists is inspiring. As we continue this exploration, we'll delve deeper into the evidence and theories surrounding underground civilizations. We'll examine ancient accounts that might be more than myth, investigate modern discoveries that challenge our understanding of Earth's structure, and consider what it would mean if we're not alone on this planet after all. The journey we're about to take will challenge your assumptions about the world beneath your feet, and invite you to consider possibilities that mainstream science doesn't acknowledge. Whether you emerge convinced or skeptical, you'll never look at the ground the same way again. Let's turn our attention to something that has puzzled scientists for decades. The Earth beneath us behaves in ways that don't always match what we expect from a solid sphere of rock and metal, and these anomalies might be telling us something important about what lies hidden in the depths. Seismic waves, those vibrations that travel through the Earth after earthquakes, should follow predictable patterns if our planet is structured the way textbooks describe. But sometimes they don't. Sometimes these waves encounter spaces where they shouldn't, reflecting and refracting in ways that suggest the presence of large voids deep underground. These aren't small caverns or pockets of gas. We're talking about spaces that could be enormous, potentially large enough to house entire ecosystems. Scientists have tried to explain these anomalies in conventional terms. They point to variations in rock density, underground water systems, or mineral deposits. And in many cases, these explanations work, but not always. There are readings that remain mysterious, signatures in the data that hint at something we haven't accounted for in our models of Earth's interior. Gravity measurements add another layer to this puzzle. The pull of gravity should be consistent based on the mass beneath any given point on Earth's surface. Yet there are places where gravitational readings are weaker than they should be, as if there's less mass below than expected. These gravitational anomalies often correspond with areas where seismic data also shows irregularities. Coincidence, perhaps? Or perhaps evidence of spaces that official geology doesn't recognize. The magnetic field presents its own mysteries. Earth's magnetic field is generated by the movement of molten iron in the outer core, at least according to current theory. But this field isn't uniform. There are places where it weakens dramatically, where compasses spin wildly, where electronic equipment malfunctions for no apparent reason. The poles are particularly notorious for this, but similar phenomena occur in other locations around the globe. What's fascinating is that many of these magnetic anomalies occur in regions that have long been associated with strange phenomena. Places where explorers have reported unusual weather patterns, where aircraft have encountered unexplained turbulence, where the very atmosphere seems different. Could these be locations where the boundary between surface and subsurface worlds is thinner? Consider the deep cave systems we continue to discover. Each year, speleologists find new networks of caverns that extend far deeper than anyone imagined possible. Some of these cave systems are so vast they create their own weather patterns. Others contain rivers and lakes that have been isolated from the surface world for millions of years, hosting life forms unlike anything found elsewhere on Earth. In these deep caves, we've found creatures that challenge our understanding of what's possible. Fish without eyes that navigate through echolocation. Bacteria that derive energy from chemical processes we barely understand. Entire ecosystems that function in complete darkness, sustained by energy sources that don't depend on sunlight. If such complex life can exist in these relatively shallow underground environments, what might exist deeper down? The deepest cave systems we know of extend only a few miles into the Earth. That leaves thousands of miles of unexplored space below. We assume it's all solid rock and molten metal, but what if it's not? What if there are spaces down there we haven't imagined, carved by geological processes we don't fully understand, or perhaps by intelligence we haven't acknowledged? Underground rivers and water systems extend far deeper than most people realize. There are aquifers hundreds of miles below the surface, vast bodies of water trapped in rock formations. Some of these water systems show signs of circulation, of movement that suggests they're part of larger networks. Where does this water go? What carved the channels it flows through? Temperature is another factor that doesn't always behave as predicted. Deep underground, temperatures should increase steadily as you approach the Earth's core. But there are places where this pattern breaks down, where pockets of cooler air exist at depths where everything should be scorching hot. Geologists explain this as the result of underground water systems or unusual rock formations. But could there be another explanation? Geothermal energy offers unlimited power for any underground civilization. The deeper you go, the more heat becomes available. An advanced society that learned to harness this energy could power incredible technologies, create artificial lighting systems, maintain comfortable temperatures year-round. They wouldn't need fossil fuels or solar panels. The planet itself would be their power source. Air circulation in deep cave systems is more sophisticated than most people realize. Natural ventilation can move fresh air through miles of tunnels, driven by temperature differences and pressure variations. Cave systems breathe, drawing in air from some openings and expelling it through others. An intelligence that understood these principles could engineer air circulation systems that would make underground cities not just possible, but comfortable. Food production underground isn't as impossible as it might seem. Many plants can grow in artificial light, and some thrive in the mineral-rich environment of caves. Mushroom cultivation requires no sunlight at all. Underground streams and pools could support fish farming. With the right knowledge, an underground civilization could develop agriculture that might be more sustainable than what we practice on the surface. The isolation of underground spaces could actually be an advantage for preserving knowledge and culture. Surface civilizations have been repeatedly set back by wars, natural disasters, and social collapse. But an underground civilization would be protected from most of these disruptions. They could develop and preserve knowledge over thousands of years without interruption. This protection might explain why ancient texts from many cultures speak of wise beings who live beneath the earth. These aren't always portrayed as primitive cave dwellers, but as advanced beings with knowledge that surface peoples have lost. Could these stories be cultural memories of contact with underground civilizations? Accounts passed down through generations, gradually transformed into myth and legend. The engineering capabilities of ancient peoples continue to surprise archaeologists. We keep discovering structures that required more sophisticated knowledge than we thought early humans possessed. Underground cities that could house thousands of people, complete with ventilation systems, storage areas, and defensive features. If surface peoples could build such things, what might underground peoples have accomplished with more time and resources? Modern mining operations sometimes encounter spaces that weren't supposed to be there. Caverns that don't appear on geological surveys. Tunnels that seem too regular to be natural. Miners have reported finding chambers with smooth walls, passages that connect in geometrically precise patterns, spaces that show signs of artificial construction. Most of these reports are dismissed or classified, but they continue to surface from operations around the world. The military's interest in underground spaces goes beyond simple strategic planning. Deep underground bases are known to exist, though their full extent and purpose remain classified. Some researchers suggest that military installations might have encountered evidence of pre-existing underground structures during construction. Could this explain some of the secrecy surrounding these facilities? Satellite imaging has revealed surface features that suggest vast underground structures. Geometric patterns visible from space, often in remote areas where no known construction has taken place. Symmetrical formations that could be natural, but which follow patterns that seem too regular to be coincidental. Ground-penetrating radar has confirmed that some of these surface features correspond to underground voids, but further investigation is often restricted. The technology for underground construction is advancing rapidly. Tunnel boring machines can now excavate passages through almost any type of rock. Underground facilities can be built with climate control, power systems, and communication networks. If we can build underground cities with current technology, what might have been possible with technologies we haven't developed yet? Or with technologies that were developed in secret, away from surface observation? Acoustic phenomena in deep underground spaces create unique possibilities for communication. Sound travels differently through rock and enclosed spaces, creating opportunities for long-distance signaling that wouldn't work on the surface. An underground civilization might have developed communication systems based on these acoustic principles, allowing them to coordinate across vast distances without electronic equipment. The psychological effects of underground living have been studied extensively, and the results are more positive than many people expect. Properly designed underground spaces can be comfortable, even pleasant to inhabit. With adequate lighting, air circulation, and space planning, underground communities could thrive. The key is understanding how to work with the unique characteristics of subterranean environments, rather than trying to recreate surface conditions. As we piece together these various elements, a picture begins to emerge. Not necessarily of one giant hollow space, but of a complex network of interconnected underground realms. Some natural, some constructed, some ancient, some relatively recent, some small and isolated, others vast and sophisticated. A hidden world that exists parallel to our surface civilization, connected by tunnels and passages that stretch across continents. The evidence isn't definitive, it's circumstantial, suggestive, intriguing. But it's enough to make you wonder, enough to question whether our understanding of what lies beneath us is complete, enough to consider the possibility that we share this planet with others we've never met. Civilizations that have chosen to remain hidden from our surface world. And if they are down there, watching and waiting, what are they waiting for? Perhaps for us to prove we're ready for contact. Perhaps for us to develop the wisdom to handle advanced knowledge responsibly. Or perhaps they're simply content to let us continue on our surface path while they pursue their own development in the depths below. The next time you feel the solid ground beneath your feet, remember that it might not be as solid as it seems. Remember that below you stretch thousands of miles of mostly unexplored space. And consider the possibility that somewhere in those depths, in chambers lit by technologies we haven't invented, communities of beings who call Earth home are living lives we can barely imagine. What's particularly compelling about the underground civilization theory is how it intersects with some of the most enduring mysteries in human history. Take the ancient accounts that appear across virtually every culture on Earth, stories that speak of beings who emerge from beneath the ground during times of crisis or transformation. The Hopi people of the American Southwest have detailed oral histories about the ant people, benevolent beings who saved their ancestors by taking them underground during great catastrophes. These weren't simple cave dwellers, but sophisticated entities who possessed advanced knowledge of agriculture, preservation, and survival in subterranean environments. The Hopi describe vast underground chambers with their own light sources and air circulation systems, places where entire populations could survive for years, while the surface world underwent dramatic changes. What's remarkable is how similar stories appear in completely unrelated cultures around the globe. Hindu texts describe elaborate underground kingdoms called Patala, realms of incredible beauty and technological advancement that exist in layers beneath our feet. Ancient Greek mythology speaks of the underworld not just as a place of the dead, but as a complex realm with its own geography, cities, and inhabitants. Norse legends tell of entire races of beings who live in underground halls and caverns. These stories share common elements that are difficult to dismiss as pure fantasy. They describe underground realms with their own sources of light, often described as gems or crystals that glow without fire. They speak of advanced agriculture that doesn't depend on sunlight. They mention sophisticated ventilation systems that keep the air fresh in deep caverns. They describe beings who possess knowledge that surface dwellers have lost or never acquired. If these were just myths, you'd expect them to vary wildly from culture to culture. But they don't. The consistency is striking. Across continents and centuries, people have told remarkably similar stories about advanced civilizations that exist beneath the Earth. Either there was some kind of ancient global communication network that allowed these stories to spread, or they're all describing something real. Consider the engineering marvels we've discovered from ancient times. The underground city of Derinkuyu in Turkey isn't just a collection of caves. It's a precisely planned urban environment that descends 18 levels into the earth. It has ventilation shafts that draw fresh air from the surface down to the deepest levels. It has storage rooms, living quarters, meeting halls, and even stables for livestock. The engineering required to create such a place suggests knowledge of underground construction that we're only beginning to appreciate, but Derinkuyu isn't unique. Similar underground cities exist throughout Turkey, some connected by tunnels that stretch for miles. In China, there are cave cities carved into cliff sides that house thousands of people. In Egypt, there are underground chambers and passages that extend far beyond what's open to the public. These aren't crude shelters dug in desperation. They're sophisticated urban environments that required advanced planning and engineering. What if these surface cities are just the tip of the iceberg? What if they're connected to much larger underground networks that we haven't discovered? Archaeological excavations are expensive and time-consuming, and most focus on surface structures. The vast underground spaces that might exist below known archaeological sites remain largely unexplored. Modern technology is beginning to reveal just how much we don't know about what lies beneath us. Ground-penetrating radar can detect voids and structures underground, and it's finding anomalies in places where conventional archaeology suggests nothing should exist. Satellite imagery can sometimes reveal surface features that correspond to underground structures, but these technologies are still limited in their range and resolution. The deeper implications of underground civilizations become even more intriguing when you consider the timeline of human development. Conventional history suggests that human civilization is only about 10,000 years old, beginning with agriculture and the first permanent settlements. But what if that's just the history of surface civilization? What if human development has been going on much longer underground, protected from the ice ages, asteroid impacts, and other catastrophes that have repeatedly disrupted surface development? An underground civilization would have had distinct advantages in terms of preserving knowledge and technology. They wouldn't have been subject to the invasions, wars, and natural disasters that have destroyed so many surface civilizations throughout history. They could have developed continuously over thousands of years, accumulating knowledge and refining technologies without the setbacks that have plagued surface societies. This could explain some of the technological mysteries we find in ancient surface civilizations, the precision of ancient construction, the sophisticated understanding of astronomy, the advanced metallurgy and engineering. Perhaps these weren't developed independently by surface peoples, but were knowledge shared from underground civilizations that had been developing these technologies over much longer periods. The isolation of underground communities could have led to very different approaches to science and technology. Without the need for weapons of war or the pressure of resource competition that has driven much surface technological development, underground civilizations might have focused on different priorities. They might have developed advanced understanding of geology, biology, and ecology. They might have created technologies that work in harmony with natural systems, rather than attempting to dominate them. Energy would be a crucial factor for any underground civilization, and the Earth itself offers abundant possibilities. Geothermal energy is available at depth virtually everywhere on the planet. The temperature differential between deep and shallow areas could drive mechanical systems. Underground water flows could generate hydroelectric power. An underground civilization might have learned to tap into these energy sources in ways that surface civilizations have barely begun to explore. The biological possibilities of underground ecosystems are only beginning to be understood. Deep caves host life forms that exist nowhere else on Earth. Creatures that have evolved unique solutions to the challenges of life without sunlight. Some of these organisms can derive energy from chemical processes rather than photosynthesis. Others have developed sensory capabilities that allow them to navigate and hunt in complete darkness. If simple organisms can thrive in these environments, more complex life forms could certainly adapt as well. Over thousands of years, human populations living underground might have developed their own unique characteristics. Enhanced hearing or other senses to compensate for reduced light. Improved ability to navigate in darkness. Perhaps even physical adaptations that we wouldn't immediately recognize as human. But the most significant developments might be cultural rather than physical. A civilization that developed in isolation from surface conflicts might have created very different social structures and values. Without the pressure of territorial competition or resource scarcity that has driven much of surface human history, they might have developed more cooperative and sustainable ways of organizing society. The question of why such a civilization would remain hidden becomes more complex when you consider it from their perspective. If they've been observing surface civilization for thousands of years, they've seen the rise and fall of empires, the development and use of increasingly destructive weapons, the environmental damage caused by industrial development. From their point of view, surface humanity might not seem ready for contact with a more advanced civilization. There's also the possibility that contact has occurred, but not in ways we would recognize or remember. Throughout history, there have been accounts of people who claim to have visited underground realms and returned with knowledge or warnings. Most of these are dismissed as fantasy or fraud. But what if some of them were real? What if there's been a careful, limited exchange of information happening for centuries? The locations where such contact might occur are revealing. Mountain caves, especially in remote areas. Deep valleys where the geology suggests extensive underground systems. Areas where the magnetic field is anomalous, or where other unusual phenomena have been reported. These are often places that have been considered sacred by indigenous peoples. locations that are treated with special reverence and caution. Modern exploration of these areas is often restricted, sometimes for environmental reasons, sometimes for cultural sensitivity, and sometimes for reasons that aren't clearly explained. But the restrictions themselves are interesting. If these areas contain nothing more than ordinary caves and rock formations, why the need for such tight control over access? The military implications of underground spaces have been recognized for decades. Deep underground bases exist in many countries, though their full extent and capabilities are classified. The technology for underground construction has advanced dramatically, making it possible to create facilities that are virtually undetectable from the surface. If military organizations can build such installations with current technology, what might have been possible with technologies developed over much longer periods? The intersection of ancient knowledge and modern capability creates fascinating possibilities. Traditional accounts of underground realms often describe technologies that seem impossible by conventional standards, but which might be achievable with approaches we haven't considered. Lighting systems that don't require fuel, air circulation that operates without mechanical ventilation, construction techniques that create spaces more durable than anything we build on the surface. Some researchers suggest that certain ancient technologies might still exist in hidden underground locations, not as museum pieces, but as functioning systems maintained by communities that never lost the knowledge of how to operate them. The idea seems fantastical, but it's worth considering that our surface civilization has lost many technologies that earlier peoples possessed. We can't build structures like the pyramids using the methods available when they were constructed. We've lost the techniques for creating Damascus steel or Roman concrete. If surface civilizations can lose such knowledge, they can also preserve it. And underground civilizations, protected from the disruptions that cause surface societies to lose their accumulated wisdom, might have maintained technological traditions that stretch back thousands of years. The implications for our understanding of human potential are profound. If there are indeed advanced civilizations living beneath our feet, it would mean that human beings are capable of creating sustainable, sophisticated societies that can persist for millennia. It would prove that the problems we face on the surface aren't insurmountable, that human ingenuity and cooperation can overcome challenges that seem impossible. Even if we never make contact with such civilizations, the possibility that they exist offers hope for our own future. It suggests that there are solutions to the problems that plague surface humanity, ways of living that are both advanced and sustainable, models of social organization that promote cooperation rather than conflict. As we continue to explore the depths beneath us, both physically and intellectually, we may discover that our planet holds more secrets than we ever imagined. The solid ground beneath our feet may be far less solid than it appears, and the world we think we know may be just one layer of a much more complex and mysterious reality. The whispers of these hidden realms grow stronger when we turn our attention to the polar regions, those frozen frontiers where conventional explanations begin to break down and mystery takes hold. There's something about the ends of our world that has always captured human imagination, and perhaps for good reason. These aren't just cold, empty wastelands. They're places where the normal rules seem to bend, where explorers have reported phenomena that don't fit neatly into our understanding of how the world works. Admiral Richard Byrd's expeditions to Antarctica in the 1940s sparked decades of speculation about what might exist at the bottom of our world. His accounts, though disputed by mainstream historians, describe encounters with landscapes that shouldn't exist according to our maps. Warm valleys in a land of perpetual ice, vegetation growing where everything should be frozen solid. Perhaps most intriguing, his descriptions of aircraft that seemed to emerge from the ice itself, operating with technologies that didn't match anything in our arsenal. Whether you believe Byrd's accounts or not, they point to something undeniably true about Antarctica. It's a continent shrouded in secrecy, governed by international treaties that restrict civilian access and limit what information reaches the public. Officially, this is for environmental protection and scientific cooperation, but the level of restriction seems disproportionate for a barren wasteland. What exactly are we being protected from? Or perhaps more accurately, what is being protected from us? The ice itself tells a story of concealment. Satellite imagery shows vast areas of Antarctica where the surface appears unnaturally smooth, as if something beneath has been carefully hidden. Ground-penetrating radar has detected massive structures under the ice, formations that don't match any known geological processes. These aren't small anomalies. We're talking about structures that could be the size of cities, buried under miles of frozen water. Recent discoveries have made these mysteries even more compelling. Scientists have found vast networks of rivers and lakes beneath the Antarctic ice, some of them larger than the Great Lakes. These aren't frozen solid as you might expect. They're liquid water, kept warm by geothermal activity from deep within the Earth. If liquid water can exist under the ice, what else might be down there? Could these subglacial waterways connect to larger spaces? Could they support life forms we've never encountered? The biology of Antarctica holds its own secrets. Life persists in this frozen realm in ways that challenge our understanding of what's possible. Microorganisms thrive in conditions that should be lethal. Some of these life forms are unlike anything found elsewhere on Earth, suggesting they've been isolated and evolving independently for millions of years. If simple life can survive and evolve in such extreme conditions, what about more complex organisms? What about intelligence that's had eons to adapt to this harsh environment? The magnetic anomalies at the poles add another layer to the mystery. Compass readings become unreliable as you approach the magnetic poles, not gradually, but often suddenly and dramatically. Electronic equipment malfunctions in ways that suggest powerful electromagnetic fields operating below the surface. These aren't subtle variations, they're dramatic disruptions that have been affecting navigation and communication for as long as humans have been exploring these regions. Some researchers have proposed that these magnetic anomalies could indicate massive metallic structures or advanced technologies operating beneath the ice. While mainstream science attributes these phenomena to natural variations in the Earth's magnetic field, the patterns don't always match what we'd expect from geological processes alone. The irregularities seem too structured, too purposeful to be entirely natural. The aurora borealis and aurora australis, those dancing lights that appear near the poles, might be more than just beautiful natural phenomena. Traditional explanations describe them as the result of solar particles interacting with Earth's magnetic field. But the lights often appear in patterns that seem almost organized, as if they're being influenced by something more than random particle collisions. Could they be side effects of energy systems operating far below the surface? Byproducts of technologies that harness the planet's magnetic field in ways we haven't discovered. Temperature readings from the polar regions reveal anomalies that standard climate models struggle to explain. There are areas where the surface temperature is significantly warmer than surrounding regions, despite no obvious source of heat. Thermal imaging from satellites shows hotspots that persist year-round, even during the harshest winter months. Geologists point to geothermal vents as the likely explanation, but the patterns don't always match what we know about volcanic activity in these regions. The restricted nature of polar exploration makes it difficult to investigate these anomalies thoroughly. Both the Arctic and Antarctic are subject to international agreements that limit where researchers can go and what they can study. Many of the most interesting thermal and magnetic anomalies occur in areas that are off-limits to civilian scientists. Military installations exist in both polar regions, though their full purpose and capabilities are classified. This brings us to one of the most intriguing aspects of the polar mystery: the involvement of military and intelligence organizations in polar research. Throughout the 20th century, major powers have maintained significant military presences in both polar regions. far beyond what would be necessary for simple territorial claims or scientific research. The scale of these operations suggests strategic interests that go beyond what's publicly acknowledged. Operation High Jump, the massive US military expedition to Antarctica in 1946-47, involved thousands of personnel and advanced equipment far beyond what would be needed for simple exploration and mapping. The operation was cut short after only a few months, despite being planned for much longer. Official explanations cite weather conditions and equipment failures, but the scale of the operation and its abrupt termination have fueled decades of speculation about what was really discovered. The timing of these polar expeditions is also significant. Many of the most intensive exploration efforts occurred immediately after World War II, when technological capabilities were advancing rapidly and geopolitical tensions were high. If advanced technologies or unusual phenomena were discovered in the polar regions during this period, the military implications would have been enormous. The Cold War context adds another dimension to polar secrecy, as both superpowers would have had strong incentives to keep such discoveries classified. Modern satellite technology has revealed features in polar regions that continue to puzzle researchers. Geometric patterns visible from space, often in areas where no known construction has occurred. Symmetrical formations that could be natural, but which follow patterns too regular to be easily explained by conventional geology. When ground teams attempt to investigate these surface features, they often find their access restricted or their equipment mysteriously malfunctioning. The indigenous peoples of polar regions have their own accounts of what lies beneath the ice. Inuit legends speak of warm lands beyond the ice, places where the aurora touches the ground and strange beings emerge from openings in the frozen earth. These stories, passed down through generations, describe encounters with entities that possess advanced knowledge and technologies. While anthropologists often interpret these as mythological accounts, the consistency and detail of such stories across different communities is remarkable. The acoustic properties of polar regions create unique opportunities for detecting underground activity. Sound travels differently through ice and frozen ground, and sensitive equipment can detect vibrations and resonances that might indicate hollow spaces or mechanical activity far below the surface. Some researchers have reported detecting rhythmic patterns in these acoustic signals, sounds that seem too regular to be entirely natural. The economics of polar regions also raise questions about hidden resources or activities. Despite the harsh conditions and enormous logistical challenges, nations continue to invest heavily in polar research and infrastructure. The scientific benefits, while real, hardly seem to justify the massive expenses involved. Could there be economic incentives that aren't publicly acknowledged? Resources or technologies that make the investment worthwhile despite the challenges? Climate change has begun to reveal features of polar regions that were previously hidden under permanent ice cover. As ice sheets retreat and melt, satellite imagery shows geological formations and surface features that don't appear on any existing maps. Some of these newly revealed areas show signs of geometric regularity or artificial construction. The timing of these revelations, as global attention focuses on climate change, adds urgency to questions about what else might be hidden under the ice. The technological challenges of polar exploration have driven innovations that seem almost beyond our current capabilities. Equipment that can operate in extreme cold, vehicles that can traverse impossible terrain, communication systems that work despite electromagnetic interference. Some of these technologies appear to be more advanced than what's available for civilian applications, suggesting that polar operations have access to classified or experimental systems. The isolation of polar regions makes them ideal locations for activities that require secrecy. Experiments that would be impossible to conceal in populated areas could operate undetected for decades in the vast emptiness of Antarctica or the Arctic. The harsh environment itself provides a natural barrier against casual observation, and the international treaty systems provide legal frameworks for restricting access. As we piece together these various elements, a picture emerges of polar regions that are far more active and mysterious than their reputation as frozen wastelands would suggest. Whether this activity involves hidden civilizations, advanced military projects, or phenomena we don't yet understand, it's clear that the poles hold secrets that go far beyond what appears in geography textbooks. The implications extend beyond mere curiosity about remote regions of our planet. If there are indeed hidden activities or civilizations in polar regions, they could represent technologies or knowledge that would transform our understanding of what's possible on Earth. The energy sources that could support such activities in harsh polar conditions would have to be far more advanced than our current capabilities. The construction techniques required to build and maintain facilities in such environments would represent engineering achievements beyond our current understanding. And if contact between surface and hidden polar civilizations has occurred, it would explain some of the most persistent mysteries in modern history. Unexplained aircraft sightings, technological leaps that seem to come from nowhere, and the curious reluctance of governments to fully disclose what they know about polar activities. The frozen ends of our world may hold keys to understanding not just our planet's hidden geography, but our species' hidden potential. The polar regions remind us that our planet still holds mysteries that challenge our assumptions about what's possible. In these frozen realms where normal rules don't apply, where technology and nature intersect in ways we don't fully understand, the boundary between the known and unknown becomes beautifully, mysteriously thin. And in that thinness, in those gaps in our knowledge, entire worlds of possibility continue to exist. The question of access brings us to one of the most puzzling aspects of this entire mystery. Why is so much of our planet off limits to ordinary exploration? The official explanations sound reasonable enough. Environmental protection, scientific preservation, safety concerns. But when you start mapping the restricted areas against the locations of unexplained phenomena, patterns begin to emerge that make you wonder if there's more to the story. Take the deep cave systems that we know exist, but can't fully explore. Many of the world's most extensive underground networks are located in areas where access is severely limited or completely prohibited. Sometimes this is due to genuine safety concerns. Cave systems can be dangerous, with risks of flooding, collapse, or toxic gases, but other times the restrictions seem disproportionate to the actual risks involved. The Mariana Trench, the deepest part of our oceans, has been visited by humans only a handful of times. We've sent more people to the moon than to the deepest parts of our own planet, and what we've found in those brief visits has been surprising. Life forms that shouldn't exist according to our understanding of biology, geological formations that don't match our models of how ocean floors develop. If such surprises exist in the relatively accessible deep ocean, what might exist in the truly inaccessible depths beneath the seafloor? Underground military installations represent another piece of this puzzle. Every major nation has them, though their extent and purpose remain classified. The technology for deep underground construction has advanced dramatically over the past few decades. Tunnel boring machines can now excavate passages through almost any type of rock. Climate control systems can maintain comfortable conditions miles below the surface. Communication networks can operate despite being buried under thousands of feet of earth and stone. What's interesting is how these military projects sometimes encounter unexpected geological features during construction. Miners and engineers have reported finding chambers that weren't supposed to be there, passages that seem too regular to be natural, spaces that show signs of previous construction or habitation. Most of these reports are classified or dismissed, but they continue to surface from projects around the world. The timing of when these underground military installations began expanding rapidly is also noteworthy. Much of the most intensive deep underground construction occurred during the Cold War, when both superpowers were developing technologies and strategies that pushed the boundaries of what was considered possible. If either side had discovered evidence of pre-existing underground civilizations or technologies during this period, it would have represented both an enormous strategic advantage and a closely guarded secret. But military secrecy is just one layer of the concealment that surrounds underground mysteries. There are also scientific, corporate, and even religious interests that might prefer certain discoveries remain hidden, advanced technologies that could disrupt existing power structures, evidence that could challenge fundamental assumptions about human history or capability, knowledge that could transform how we understand our relationship with the planet we inhabit. The control of information about underground phenomena extends beyond direct censorship to more subtle forms of influence. Research funding tends to flow toward conventional projects, while more speculative investigations struggle to find support. Academic careers can be damaged by association with theories that are considered too far outside the mainstream. Media coverage of underground mysteries is often relegated to entertainment rather than serious journalism. Yet despite these barriers, information continues to leak out. Satellite imagery that reveals surface features suggesting vast underground structures. Seismic data that shows anomalies conventional geology can't explain. Gravitational measurements that indicate large voids where solid rock should exist. The technology that allows us to study the Earth's interior is advancing faster than the ability to control what that technology reveals. Ground-penetrating radar has become particularly revealing in this regard. This technology can detect underground voids, structures, and anomalies with increasing precision and range. Archaeological teams use it to locate buried ruins. Geologists use it to map underground water systems and mineral deposits. But sometimes it reveals things that don't fit into either category. Structures that are too large or too regular to be natural, but too old or too deep to be recent human construction. The response to these discoveries is often telling. When ground-penetrating radar reveals a buried temple or ancient settlement, it makes headlines and attracts research funding. But when the same technology reveals massive underground structures that don't match any known archaeological patterns, the results tend to be quietly filed away or dismissed as equipment malfunctions. This selective attention to underground discoveries suggests that there are categories of findings that various institutions would prefer not to publicize. The question is why? What could be so significant about underground structures or phenomena that their existence needs to be concealed or downplayed? One possibility is that the discoveries are so far outside our current understanding that they would force fundamental revisions to accepted theories about geology, archaeology, or human history. Scientific institutions are naturally conservative, resistant to dramatic paradigm shifts that would invalidate decades of established research. If underground discoveries suggested that human civilization is far older or more advanced than currently believed, the implications would ripple through multiple academic disciplines. Another possibility is that the discoveries have technological implications that are considered too sensitive for public knowledge. If underground civilizations possess advanced technologies, access to those technologies could provide enormous strategic or economic advantages. Nations or organizations that gained such access would have strong incentives to keep their discoveries secret while they work to understand and replicate what they had found. The energy implications alone could be revolutionary. Any civilization that has thrived underground for thousands of years would have had to solve energy problems that we're still struggling with on the surface. They would have needed clean, sustainable power sources that could operate reliably in isolated underground environments. If such technologies exist and could be understood and adapted, they could transform our approach to energy production and environmental sustainability. The biological implications are equally significant. Life forms that have evolved in deep underground environments might possess capabilities that could revolutionize medicine, materials science, or biotechnology. Organisms that can thrive in extreme conditions, that can derive energy from chemical processes we don't fully understand, that have developed unique sensory or metabolic capabilities, could provide blueprints for technologies we haven't imagined. but perhaps the most significant implications are social and philosophical. If advanced civilizations exist beneath our feet, it would prove that human beings are capable of creating sustainable, sophisticated societies that can persist for millennia. It would demonstrate that the problems we face on the surface, the conflicts and environmental destruction that seem so intractable, are not inevitable features of human nature, but challenges that can be overcome. This possibility might be the most threatening of all to existing power structures. If underground civilizations have solved problems like sustainable energy, social harmony, and long-term environmental stewardship, their existence would raise uncomfortable questions about why surface civilizations continue to struggle with these same challenges. It might suggest that the obstacles to solving these problems are not technological or natural, but political and economic. The concealment of underground civilizations, if it exists, might therefore serve multiple purposes. Protecting advanced technologies from exploitation. Preventing social upheaval that might result from the revelation that alternative forms of human organization are not only possible, but successful. Maintaining the stability of existing institutions and power relationships that might be undermined by evidence of more effective alternatives. This web of concealment creates a curious paradox. The more evidence that accumulates for underground civilizations or advanced underground technologies, the more incentive there is to suppress or discredit that evidence. The very significance of such discoveries ensures that they would be among the most closely guarded secrets on Earth. Yet secrecy has its limits. In an age of global communication and advancing technology, it becomes increasingly difficult to suppress information completely. Satellite imagery is available to anyone with an internet connection. Scientific equipment becomes more accessible and more powerful each year. Independent researchers can collaborate across national boundaries and institutional barriers. The result is a growing accumulation of anomalous data and unexplained phenomena that suggests our understanding of what lies beneath us is incomplete. Seismic readings that don't match geological models, gravitational measurements that indicate large voids where none should exist, electromagnetic anomalies that suggest massive metallic structures or advanced technologies operating far below the surface. Each piece of evidence taken alone might be dismissed as measurement error or natural variation, but collectively, they paint a picture of an Earth that is far more complex and mysterious than our textbooks suggest. A planet where vast spaces exist in regions we assume are solid rock, where energy and information might flow through networks we haven't discovered, where intelligence might have found ways to thrive in environments we consider impossible for complex life. The concealment, whether deliberate or simply the result of limited exploration capabilities, ensures that these mysteries remain unsolved, but it also ensures that they continue to capture human imagination and drive human curiosity. In the gaps between what we know and what we assume, entire worlds of possibility continue to exist. And perhaps that's exactly as it should be. Perhaps some mysteries are more valuable as mysteries than they would be as solved problems. Perhaps the possibility of hidden civilizations beneath our feet serves an important function in keeping us humble about our place in the universe and curious about the limits of our knowledge. The concealed realms beneath us remind us that our planet still holds secrets, that human understanding, for all its advances, remains incomplete, that the solid ground beneath our feet might be far less solid and far more wonderful than we dare to imagine. As we continue to develop new technologies for exploring the depths, as we push deeper into cave systems and drill further into the Earth's crust, we may eventually uncover definitive evidence of what lies hidden below, or we may find that the mystery only deepens, that each answer leads to new questions, that the underground world is even more complex and surprising than our most ambitious theories suggest. Either way, the search itself transforms us. It expands our conception of what's possible. It challenges our assumptions about the world we inhabit. And it reminds us that some of the greatest discoveries may be waiting not in distant galaxies or exotic dimensions, but right here beneath our feet, in the hidden spaces of our own planet. Until now, we've been exploring the theoretical possibilities and circumstantial evidence for underground civilizations. But what if the proof has been hiding in plain sight all along? What if the technologies that would make such civilizations possible aren't just hypothetical, but are demonstrated by phenomena we can observe and measure right now? Consider the mysterious hum that people report hearing in certain locations around the world. It's a low-frequency sound that seems to come from deep underground, persistent and rhythmic, like the heartbeat of the planet itself. Scientists have recorded this phenomenon in dozens of locations, from Taos, New Mexico, to Bristol, England. The sound is real, measurable, and consistent, but its source remains unexplained. Conventional theories point to industrial activity, ocean waves, or seismic activity, but the hum often occurs in areas far from any industrial operations, and its frequency patterns don't match natural geological processes. What if this sound is actually the acoustic signature of vast underground machinery, energy systems that have been operating for centuries, maintaining the infrastructure of hidden civilizations? The frequency of these sounds is particularly intriguing. They often fall within ranges that are known to have biological effects, frequencies that can influence human consciousness and physical well-being. If an underground civilization wanted to communicate with surface dwellers or influence their behavior, these specific frequencies would be exactly what they might use. Underground water systems offer another window into the hidden infrastructure that might exist beneath us. We know that vast networks of rivers and aquifers flow through the Earth's crust, some of them larger than any surface river system. But the behavior of these underground waterways sometimes defies conventional hydrology. Water appears in places where it shouldn't exist, according to our understanding of geological processes. Springs emerge from solid rock with no apparent source. Underground rivers change course without explanation. Water temperatures vary in patterns that don't match the surrounding geology. These anomalies could indicate that underground water systems are being managed or modified by intelligence. The chemistry of some underground water sources is equally mysterious. Minerals appear in combinations that shouldn't occur naturally. Water emerges from deep sources with unusual properties, sometimes described as having healing or energizing effects. While some of this can be explained by rare geological processes, the patterns suggest that underground water systems might be more than just natural phenomena. Cave systems themselves continue to reveal surprises that challenge our understanding of what's possible underground. The mobile cave in Romania was sealed off from the surface world for over 5 million years, yet it hosts a complete ecosystem of creatures found nowhere else on Earth. These organisms have evolved unique metabolic processes that don't depend on sunlight or surface nutrients. They represent proof that complex life can not only survive, but thrive in complete isolation from surface conditions. If simple organisms can evolve such sophisticated adaptations in isolated underground environments, what might more complex life forms have achieved with millions of years of uninterrupted development? The biological creativity we see in deep caves suggests that underground evolution might follow paths we haven't imagined. Bioluminescence is particularly common in deep cave ecosystems. Organisms that generate their own light through chemical processes, creating living illumination systems that require no external energy source. Scale this up to a civilization level, and you have a technology that could light entire underground cities without any need for fuel or electrical power. The acoustic properties of underground spaces create possibilities for communication and coordination that don't exist on the surface. Sound travels through rock and underground chambers in predictable ways, allowing for long-distance signaling across vast underground networks. Certain frequencies can travel for miles through underground passages with minimal loss of clarity. An underground civilization that understood these acoustic principles could maintain communication across continental distances using natural cave acoustics enhanced by precisely positioned chambers and passages. They could coordinate activities, share information, and maintain social cohesion across territories that would be impossible to manage using surface communication methods. The thermal properties of underground environments offer similar advantages. Geothermal energy is available virtually everywhere if you dig deep enough. The temperature differential between deep and shallow underground areas could power mechanical systems. Underground thermal currents could provide heating and cooling for large installations without any external energy input. What's particularly interesting is how these natural underground energy sources could be enhanced or directed using relatively simple engineering principles. Thermal siphons could move heat from deep geothermal sources to areas where it's needed. Underground air currents could be channeled and amplified to provide ventilation and power. Water flow could be managed to generate hydroelectric power even in areas far from surface rivers. The engineering required for such systems wouldn't necessarily be beyond the capabilities of ancient peoples, especially if they had thousands of years to develop and refine their techniques. The key would be understanding how to work with natural underground processes, rather than trying to impose surface-style technologies on underground environments. Modern deep mining operations occasionally encounter evidence that suggests previous underground activity. Miners report finding chambers with smooth walls that seem too regular to be natural, passages that connect in geometrically precise patterns, spaces that show signs of artificial construction, but which predate any known mining activity in the area. Most of these reports are dismissed as natural geological formations or misidentified features of the mining process itself. But the consistency of such accounts from independent operations around the world suggests that there might be more to these discoveries than official explanations acknowledge. The tools marks found in some of these spaces are particularly puzzling. They show evidence of cutting or shaping techniques that don't match any known ancient tools. The precision and consistency of the marks suggest advanced understanding of stoneworking and engineering. Yet they're found in locations that were supposedly inaccessible until modern mining equipment reached them. Deep drilling operations have revealed similar anomalies. Drill cores sometimes contain materials or structures that don't match the expected geological layers. Voids appear where solid rock should exist. Metallic objects are found embedded in stone formations that are supposedly millions of years old. These discoveries are rarely publicized because they don't fit into established geological or archaeological frameworks, but they accumulate in technical reports and private collections, creating a body of evidence that suggests our understanding of underground history is incomplete. The electromagnetic properties of certain underground locations add another dimension to these mysteries. Areas where compass readings become unreliable, where electronic equipment malfunctions, where radio signals are amplified or distorted in unusual ways. These phenomena often occur in locations that also show other signs of underground anomalies. If underground civilizations use technologies based on electromagnetic principles we don't fully understand, they could create field effects that would interfere with surface equipment. The patterns of electromagnetic disturbance might even serve as a form of communication or navigation system for underground inhabitants. Satellite imagery has revealed surface features in remote areas that suggest large-scale underground construction. Geometric patterns that are visible from space, but which correspond to no known human activity. Symmetrical formations that could be natural, but which follow mathematical relationships, too precise to be easily explained by geological processes. Ground-penetrating radar surveys of these areas often reveal underground structures that match the surface patterns. But access to many of these locations is restricted, either by geographical barriers, political boundaries, or official prohibitions. The few investigations that have been conducted often encounter bureaucratic obstacles or technical difficulties that prevent thorough exploration. The timeline of when these surface features appeared adds to their mystery. Some seem to have been present for decades or centuries, suggesting they're not recent human constructions. Others appear to change over time, growing or shifting in ways that suggest ongoing activity beneath the surface. The biological evidence for underground civilizations might be the most compelling of all. Genetic studies of certain human populations show unusual characteristics that don't fit standard models of human migration and development. DNA markers that suggest long periods of isolation and adaptation to specific environmental conditions. Some of these populations show physical adaptations that would be advantageous for underground living. Enhanced night vision, improved hearing, increased lung capacity, stronger bone density. These traits appear in populations from various parts of the world, but always in areas where extensive cave systems or underground construction is known to exist. The cultural knowledge preserved by these populations is equally intriguing. Traditional stories that describe advanced underground civilizations in remarkable detail. Engineering knowledge that seems beyond what would be expected from surface-dwelling peoples. Understanding of underground navigation, construction techniques, and resource management that suggests extensive practical experience with subterranean environments. Archaeological evidence from surface excavations sometimes reveals artifacts that don't match known ancient technologies, tools that show understanding of metallurgy or engineering principles that weren't supposed to have been developed until much later periods, construction techniques that required knowledge of physics and material science that seemed beyond the capabilities of ancient peoples. When these artifacts are found in association with evidence of extensive underground construction, they suggest that ancient surface civilizations might have had access to knowledge and technologies developed by underground communities. The exchange of information between surface and underground civilizations might have been occurring for thousands of years. The implications of this possibility extend far beyond archaeology or geology. If underground civilizations have been developing advanced technologies while remaining hidden from surface view, they represent a parallel track of human development that has proceeded independently of recorded history. The technologies they might have developed would be specifically adapted to underground conditions. Energy systems that work without surface resources. Construction techniques that can create durable structures in challenging underground environments. Life support systems that can maintain comfortable conditions in spaces far from surface air and water sources. Such technologies could revolutionize our approach to sustainability and resource management. Underground civilizations would have had to solve problems of waste management, energy efficiency, and ecological balance that surface civilizations are still struggling with. Their solutions might offer blueprints for creating more sustainable surface communities. The social organization of underground civilizations might be equally valuable. Communities that have maintained stability and cooperation over thousands of years would have had to develop social structures and cultural practices that promote harmony rather than conflict. Their approaches to governance, education, and social coordination could offer alternatives to the systems that have led to so much strife in surface civilizations. But perhaps the most significant implication is what the existence of underground civilizations would mean for our understanding of human potential. If people living in challenging underground environments have created advanced, sustainable societies, it would prove that the problems facing surface humanity are not insurmountable limitations of human nature, but challenges that can be solved with the right knowledge and approach. The evidence continues to accumulate, piece by piece, measurement by measurement, discovery by discovery. Each anomaly might be explainable in isolation, but collectively, they paint a picture of an Earth that is far more complex and active than our surface perspective suggests. Underground networks of passages, chambers, and installations that could house entire civilizations. Energy systems that could power advanced technologies. Communication networks that could coordinate activities across vast distances. Whether these systems are natural phenomena we don't yet understand, remnants of ancient surface civilizations we've forgotten, or evidence of ongoing underground communities we haven't recognized, they remind us that our planet holds mysteries that challenge our assumptions about what's possible in the world beneath our feet. The search for these hidden realms continues, driven by advancing technology and persistent human curiosity. Deep drilling projects push further into the Earth's crust. Cave exploration reaches deeper into uncharted underground territories. Satellite surveillance reveals more surface features that suggest underground activity. Each advance in our capabilities brings us closer to definitive answers about what lies hidden in the depths. But even as we search for proof, the possibility itself transforms our understanding of our place in the world. We walk on ground that might conceal entire civilizations. We live on a planet that might host forms of human development we've never imagined. The solid Earth beneath us might be far less solid and far more alive with hidden activity than we've ever dared to consider. And in that possibility, in the space between what we know and what we might discover, entire worlds of wonder continue to exist, waiting in the depths, patient as stone, mysterious as the darkness that has concealed them for so long. The greatest adventure of discovery might not require traveling to distant stars or exotic dimensions, but simply looking down into the hidden heart of our own planet, where secrets older than recorded history might still be keeping their ancient vigil in the depths below. Deep beneath the familiar rhythms of our surface world, where tectonic plates shift with the patience of eons and molten currents spiral through the Earth's core, lie phenomena that suggest our planet operates on principles we're only beginning to glimpse. The very forces that we assume govern the solid ground beneath us might be far more complex, far more alive with possibility than our textbooks dare to suggest. Consider the peculiar behavior of gravity in certain underground locations. Standard physics tells us that gravitational pull should increase steadily as we descend toward the Earth's center, where mass concentrates most densely. Yet sensitive instruments have detected zones where this rule seems to bend. Areas deep underground where gravitational readings fluctuate in patterns that don't match our models of how mass should be distributed through solid rock. These aren't subtle variations that require sophisticated equipment to detect. In some locations, the gravitational anomalies are significant enough to affect the behavior of water, the settling of sediment, even the growth patterns of crystalline formations. It's as if something in these deep spaces is redistributing mass in ways that conventional geology can't explain. What could create such effects? One possibility is that large voids exist where we expect solid matter, but these wouldn't be simple caves or natural chambers. The gravitational signatures suggest spaces that are actively managed, where mass is arranged according to principles that work with gravitational forces, rather than simply yielding to them. This hints at engineering on a scale we've never attempted. Not just the excavation of spaces within solid rock, but the deliberate manipulation of gravitational fields to create environments where different physical laws apply. Zones where objects might fall upward instead of down, where water could flow in spirals that defy surface physics, where the very orientation of up and down might be subject to conscious design. The implications extend beyond mere construction techniques. If gravitational fields can be manipulated with sufficient precision, it would revolutionize our understanding of energy, transportation, and materials science. Technologies that harness gravitational differential could provide unlimited clean power. Transportation systems that work with gravity rather than against it could move people and materials with minimal energy input. But gravity is just one piece of a larger puzzle. Deep underground monitoring stations have detected acoustic patterns that suggest the Earth's interior is far more active than we assume. These aren't the random vibrations you'd expect from settling rock or tectonic movement. They're rhythmic, structured, almost musical in their complexity. The frequencies involved are particularly intriguing. Many of them fall within ranges that have known biological effects. Frequencies that can influence cellular metabolism, neural activity, even consciousness itself. If these sounds are artificial, they represent a technology that could affect living systems across vast distances, using the Earth itself as a transmission medium. Sound travels through rock and underground chambers in predictable ways, But the acoustic signatures detected by deep monitoring equipment show properties that don't match simple sound transmission. They demonstrate interference patterns, harmonic relationships, and frequency modulations that suggest active management by intelligence that understands acoustic principles far better than surface science has achieved. These acoustic networks could serve multiple purposes: communication across continental distances, using natural underground chambers as resonating spaces; environmental control, using specific frequencies to influence biological processes in underground ecosystems; even consciousness alteration, using sound to induce states of awareness that facilitate contact between surface and underground communities. The biological evidence grows more compelling when we examine the life forms that thrive in deep underground environments. These aren't primitive organisms barely clinging to existence in harsh conditions. They're sophisticated life forms that have developed capabilities we're only beginning to understand. Some deep cave organisms demonstrate collective intelligence, coordinating their behavior across entire underground ecosystems in ways that suggest communication networks we can't detect with current instruments. Others show adaptive capabilities that allow them to modify their environment, creating conditions that support not just their own survival, but the flourishing of entire underground biospheres. The metabolic processes of these organisms often don't require any input from surface ecosystems. They derive energy from chemical processes that tap into the Earth's internal energy sources. Some appear to be photosynthetic, but using light sources that don't originate from the sun. Others demonstrate what can only be described as engineered biology, metabolic pathways that seem too efficient and too precisely adapted to their environments to have evolved through random processes alone. If such sophisticated biological systems can emerge naturally in underground environments, what might be possible with conscious direction? Underground civilizations could have developed biotechnology that makes their environments not just habitable, but luxurious. Living architecture that grows and adapts to changing needs. Biological systems that provide light, heat, air purification, and waste processing without any mechanical components. The energy systems that could support such civilizations become clearer when we examine the thermal properties of deep underground environments. Geothermal energy is available everywhere if you know how to access it. But the thermal signatures detected by deep sensing equipment suggest that this energy is being harnessed in ways that go far beyond simple heating and cooling. Temperature differentials in certain underground locations create patterns that look engineered. Thermal currents that flow in spirals and geometric arrangements that maximize energy transfer. Heat distribution systems that maintain precise temperatures across vast underground spaces. These thermal management systems would require understanding of thermodynamics and materials science that surpasses current surface capabilities. But the most intriguing thermal signatures are those that suggest active cooling in areas where temperatures should be rising due to geothermal activity. These cooling zones often correspond with gravitational and acoustic anomalies, suggesting that all three phenomena are aspects of integrated systems that manage the physical properties of underground environments. Electromagnetic phenomena provide another window into the hidden infrastructure that might exist beneath us. Deep underground monitoring equipment has detected electromagnetic fields with properties that don't match any known natural processes. These fields show organization, structure, and patterns that suggest they're being generated and controlled by advanced technology. The strength and precision of these electromagnetic effects would allow for technologies we can barely imagine. Power transmission without wires, using the Earth itself as a conductor. Communication systems that operate through electromagnetic resonance in underground chambers. Even transportation systems that use electromagnetic fields to move objects through underground passages without friction or mechanical contact. Some of these electromagnetic signatures pulse in rhythms that match biological processes, suggesting that underground civilizations might have developed technologies that integrate seamlessly with living systems. Electromagnetic fields that enhance biological functions, support healing processes, or facilitate communication between biological and technological systems. The precision of these electromagnetic effects is particularly remarkable. They demonstrate frequency control, field shaping, and energy management capabilities that our surface technology is only beginning to approach. If these are artificial phenomena, they represent engineering achievements that would transform every aspect of how we understand energy and matter. Water management in deep underground environments reveals another layer of sophisticated infrastructure. Underground water systems don't behave the way surface hydrology predicts. Water appears in locations where geological models say it shouldn't exist. It flows in patterns that don't match gravitational gradients. It maintains temperatures and chemical compositions that suggest active management by systems we haven't identified. The chemistry of some underground water sources defies conventional explanation. Mineral compositions that shouldn't occur naturally, pH levels that remain stable despite conditions that should cause dramatic fluctuations, dissolved gases and trace elements that suggest the water is interacting with systems that don't appear in geological surveys. But perhaps most intriguingly, some underground water systems show signs of biological activity that doesn't match any known ecosystem. Microorganisms with capabilities that seem engineered rather than evolved. Chemical processes that appear to be managed by biological systems working in coordination with technological infrastructure. These water management systems could support underground civilizations with capabilities we're only beginning to imagine. Closed-loop systems that recycle and purify water with perfect efficiency. Biological treatment systems that can process any type of contamination. Distribution networks that can deliver precisely controlled water chemistry to different areas based on specific needs. The integration of all these systems suggests something far more sophisticated than isolated underground communities, scratching out a basic existence in cave systems. The evidence points to civilizations that have developed technologies specifically adapted to underground environments, technologies that work with natural underground processes rather than trying to impose surface-style solutions on subterranean conditions. These underground technologies would have advantages that surface technologies lack. They would be protected from weather, warfare, and most natural disasters. They would have access to unlimited geothermal energy. They would operate in stable environments where precise control of physical conditions is possible. Most importantly, they could develop over thousands of years without the interruptions that have repeatedly set back surface civilizations. The materials science required for such underground infrastructure would be unlike anything we've developed on the surface. Materials that can withstand the unique stresses of underground construction, while maintaining precision and durability over geological timescales. Construction techniques that work with underground pressure and thermal conditions rather than fighting against them. Archaeological evidence from deep excavations occasionally reveals artifacts that don't match known ancient technologies. Metal alloys with properties that modern metallurgy struggles to reproduce. Construction materials that show no signs of degradation despite being buried for millennia. Tool marks that suggest cutting and shaping techniques more precise than anything achievable with known ancient methods. These artifacts are often dismissed as anomalies or misidentified modern contamination. But their consistency across different locations and geological contexts suggests they might be evidence of technological traditions that developed independently of surface civilizations. Technologies specifically designed for underground conditions, using principles and materials that surface science has yet to discover. The timeline of underground development could stretch back far longer than surface civilization. While surface communities have been repeatedly disrupted by ice ages, asteroid impacts, and other catastrophes, underground civilizations would have been protected from most of these disruptions. They could have maintained continuous technological development over hundreds of thousands of years. This extended timeline would allow for achievements that seem impossible from a surface perspective. Technologies refined over millennia of uninterrupted development. Social systems that have evolved solutions to problems that surface civilizations are still struggling with. Knowledge accumulated over timescales that dwarf recorded human history. The biological adaptations that might have developed in underground human populations over such timescales would be subtle but significant. Enhanced night vision, improved hearing, stronger bone density, more efficient metabolism. These wouldn't be dramatic physical changes, but refinements that would make underground life not just possible but comfortable. More importantly, the cultural and intellectual adaptations could be profound. Communities that have maintained social harmony for thousands of years would have developed approaches to governance, education, and social organization that promote cooperation and sustainability. Their solutions to social problems could offer blueprints for creating more harmonious surface communities. The question of why such civilizations would remain hidden becomes more complex when viewed from their perspective. If they've been observing surface civilization for thousands of years, they've witnessed the rise and fall of empires, the development of increasingly destructive weapons, the environmental damage caused by industrial technology. From their viewpoint, surface humanity might seem unprepared for contact with more advanced civilizations, but concealment might also serve protective purposes. Underground civilizations would be vulnerable to disruption if their locations and technologies became widely known. Their carefully maintained environments could be damaged by inappropriate contact. Their social systems could be destabilized by exposure to surface conflicts and competitions. The energy required to maintain such concealment would be enormous by surface standards, but trivial for civilizations with access to unlimited geothermal power and thousands of years to develop efficient systems. Electromagnetic shielding that deflects detection equipment, acoustic dampening that prevents sound from reaching surface monitoring stations, thermal management that masks heat signatures from satellite surveillance. These concealment technologies might be so sophisticated that they operate below the threshold of surface detection capabilities, not actively jamming or blocking surface sensors, but simply ensuring that underground activities don't create signatures that surface technology is designed to recognize. The philosophical implications of such civilizations are as significant as the technological ones. If advanced underground communities exist, they prove that human beings are capable of creating sustainable, sophisticated societies that can persist for millennia. They demonstrate that the problems facing surface humanity are not inevitable limitations of human nature, but challenges that can be solved with appropriate knowledge and social organization. This possibility offers hope for surface civilization's future. It suggests that sustainable technology and social harmony are achievable goals rather than impossible ideals. The solutions exist, developed and refined by communities that have had the time and stability to work out the details of how to live well on this planet. But it also raises uncomfortable questions about why surface civilizations continue to struggle with problems that might already have been solved. Are the obstacles technological, or are they political and economic? Do the barriers to sustainable development lie in the limitations of human capability, or in the structures of power and competition that prevent the implementation of solutions? The detection of underground civilizations, if they exist, may ultimately depend on their willingness to be detected, rather than on improvements in our surveillance technology. Their concealment capabilities are likely to remain ahead of our detection capabilities for the foreseeable future. Contact, if it occurs, will probably happen on their terms and according to their timeline. In the meantime, the search continues. Deep drilling projects push further into unexplored regions of the Earth's crust. Cave exploration teams map deeper into uncharted underground territories. Monitoring systems detect more anomalies that challenge conventional understanding of what lies beneath us. Each discovery brings us closer to answering fundamental questions about our planet and our place on it. Are we alone on Earth, or do we share it with civilizations we've never recognized? Are the technologies we need to solve surface problems already developed and operating in hidden locations beneath our feet? Is human potential far greater than our surface history suggests? The answers to these questions may transform not just our understanding of Earth, but our vision of what human civilization could become. In the depths below, patient as stone and mysterious as the darkness that conceals them, possibilities wait that could reshape our entire relationship with the planet we call home. As we stand at this threshold between the known and the unknown, between the solid certainty we think we understand and the fluid mystery that might exist beneath us, we find ourselves confronting something far more profound than mere scientific curiosity. We're facing questions that strike at the very heart of what it means to be human on this planet. Think about the moment when you first learned that the ground beneath your childhood home was not the bottom of everything. That beyond the basement, beyond the foundation, the earth continued downward for thousands of miles. That realization probably felt both thrilling and slightly terrifying. The solid world you knew suddenly became a thin shell floating on vast unknowns. Now multiply that feeling by everything we've explored tonight. Every seismic anomaly that suggests hollow spaces where textbooks say there should be solid rock. Every gravitational reading that doesn't match our models of how mass should behave. Every acoustic signature that sounds too organized, too purposeful to be random geological noise. Each piece of evidence chips away at our assumptions about the world we inhabit, but perhaps the most unsettling realization is how little we actually know about the planet we call home. We've explored less than 1% of the Earth's volume. We've mapped the surface of Mars in greater detail than we've mapped the deepest parts of our own oceans. We've sent probes to the outer reaches of our solar system while leaving vast portions of our own world completely uncharted. This ignorance isn't accidental. It's the result of physical limitations, technological constraints, and perhaps most significantly, the simple fact that underground exploration is extraordinarily difficult and expensive. Every mile deeper we go, conditions become more challenging. Pressure increases, temperatures rise, equipment fails. The Earth itself seems to resist our attempts to penetrate its secrets. Yet some of the most compelling evidence for underground civilizations comes precisely from these extreme environments. The life forms we discover in deep caves aren't struggling to survive. They're thriving. They've developed capabilities that seem almost engineered for their environments. They demonstrate that life doesn't just adapt to impossible conditions. It can master them, transform them, make them hospitable for increasingly complex forms of existence. If simple organisms can achieve such mastery over underground environments, what might intelligent life accomplish with thousands of years of uninterrupted development? What might human communities achieve if they had the time, the resources, and the motivation to truly understand how to live within the Earth rather than merely upon it? The archaeological evidence we've examined suggests that ancient peoples understood underground environments far better than we've given them credit for. The precision of their underground construction, the sophistication of their ventilation systems, the way they integrated their underground spaces with natural geological features. These weren't primitive shelters, dug in desperation. They were carefully planned urban environments that required advanced understanding of engineering principles we're still learning to appreciate. But what if these surface manifestations of underground knowledge are just the visible portion of something much larger? What if the underground cities we've discovered are like the tips of icebergs, small surface expressions of vast underground networks that we haven't even begun to map? The energy requirements for such networks would be enormous by surface standards. But underground, energy is everywhere. Geothermal power is available virtually anywhere if you dig deep enough. The temperature differential between different underground levels could drive mechanical systems. Underground water flow could generate hydroelectric power. An advanced underground civilization might have access to more clean energy than all surface civilizations combined. The materials science required for underground construction would be unlike anything we've developed. Materials that could withstand tremendous pressure while maintaining structural integrity over geological timescales. Construction techniques that work with underground forces rather than fighting against them. But the evidence suggests that such materials and techniques might already exist, developed by communities that have had centuries to perfect their understanding of underground engineering. The social implications might be even more significant than the technological ones. Communities that have maintained stability and cooperation for thousands of years would have had to solve problems that surface civilizations are still struggling with. How do you create social systems that promote harmony rather than conflict? How do you manage resources sustainably over extended periods? How do you preserve and transmit knowledge across generations without losing essential information to war, disaster, or social upheaval? Underground civilizations would have been forced to develop solutions to these problems simply to survive. They couldn't afford the luxury of wasteful competition or destructive conflicts. Their environments would have demanded cooperation, efficiency, and long-term thinking. The social technologies they developed might be as advanced as their physical technologies. This brings us to perhaps the most intriguing question of all. If such civilizations exist, why haven't they made contact with surface humanity? The answer might lie not in their capabilities, but in their assessment of our readiness for such contact. From the perspective of an advanced underground civilization, surface humanity might appear chaotic, destructive, and unpredictable. Our history is marked by wars, environmental destruction, and social conflicts that would seem incomprehensible to communities that have maintained peace and sustainability for millennia. We might seem like children playing with dangerous toys, not yet mature enough to handle advanced knowledge responsibly. But there's another possibility. Contact might already be occurring, but in ways so subtle that we don't recognize it as contact. Throughout history, there have been accounts of people who claim to have encountered beings with advanced knowledge who emerged from underground locations. Most of these accounts are dismissed as fantasy or fraud. But what if some of them represent real contact events, carefully managed interactions designed to share specific knowledge without disrupting surface civilizations? The timing of certain technological breakthroughs in surface history is intriguing when viewed from this perspective. Advances that seem to come from nowhere. Discoveries that required leaps of insight that seem almost impossible given the available knowledge base. Could some of these breakthroughs have been guided by underground civilizations sharing carefully selected information with surface inventors and scientists? The locations where such contact might occur are revealing. Remote cave systems where the boundary between surface and underground worlds is thinnest. Areas where magnetic and gravitational anomalies create conditions that might facilitate communication between different realms of existence. Places that have been considered sacred by indigenous peoples for reasons that might be more practical than mystical. Modern exploration of these areas is often restricted, sometimes for environmental reasons, sometimes for cultural sensitivity, and sometimes for reasons that aren't clearly explained. But the restrictions themselves raise questions. If these areas contain nothing more than ordinary geological features, why the need for such tight control over access? The implications of underground civilizations extend far beyond academic curiosity. If such communities exist, they represent proof that human beings are capable of creating sustainable, advanced societies that can persist for millennia. They offer hope that the problems facing surface civilization are not insurmountable limitations of human nature, but challenges that can be solved with appropriate knowledge and social organization. The technologies they might possess could revolutionize surface civilization. Clean energy systems that work in harmony with natural processes. Construction techniques that create durable structures without environmental damage. Social systems that promote cooperation and long-term thinking rather than competition and short-term gain. But perhaps most importantly, their existence would prove that there are alternatives to the path surface civilization has been following. That sustainable development isn't just a hopeful ideal, but an achievable reality. That human communities can thrive without destroying their environment or engaging in destructive conflicts with each other. The search for evidence of underground civilizations is ultimately a search for evidence of human potential. Every anomaly we discover in the depths beneath us is a reminder that our understanding of what's possible is still evolving. Every unexplained phenomenon we encounter suggests that reality might be far more complex and wonderful than our current theories acknowledge. The ground beneath your feet right now might be far more alive with hidden activity than you've ever imagined. The solid earth that seems so permanent and unchanging might conceal networks of passages, chambers, and installations that house entire civilizations. The planet we think we know might be just the outermost layer of a much more complex and mysterious reality. As our technology advances and our exploration capabilities improve, we move closer to definitive answers about what lies hidden in the depths. Deep drilling projects push further into unexplored regions. Monitoring systems become more sensitive to subtle anomalies. Cave exploration teams map deeper into uncharted territories. Each advance brings us closer to the moment when we might finally encounter direct evidence of what we've been seeking, a chamber that's clearly artificial. Technology that's obviously beyond current surface capabilities. Contact with beings who have been living in the depths all along, waiting for us to develop the wisdom and maturity necessary for meaningful communication. But even if that moment never comes, even if the mystery remains unsolved, the search itself changes us. It expands our conception of what might be possible. It challenges our assumptions about the limits of human achievement. It reminds us that our planet still holds secrets that could transform our understanding of ourselves and our place in the universe. The possibility of underground civilizations invites us to think differently about our relationship with the Earth. Instead of seeing it as a resource to be exploited, we might begin to see it as a partner in a much larger conversation. Instead of viewing the surface as the only realm that matters, we might recognize that we're part of a planetary system that extends far deeper than we've ever explored. The depths beneath us might hold not just physical spaces, but entire worlds of possibility. Communities that have solved problems we're still struggling with. Technologies that could heal the damage we've done to our environment. Social systems that could teach us how to live together in harmony rather than conflict. Whether these possibilities exist in reality or only in our imagination, they serve an important function. They remind us that human potential extends far beyond what we've achieved so far. They suggest that the future might hold solutions to problems that seem insurmountable today. They offer hope that somewhere, whether in hidden depths or future developments, human wisdom and ingenuity can create something better than what we have now. The journey into the depths of our planet is ultimately a journey into the depths of human possibility. In the darkness below, in the spaces we haven't yet explored, in the mysteries we haven't yet solved, entire worlds of wonder might be waiting. And in our search for those worlds, we might discover that the greatest treasures aren't hidden in distant depths, but in our own capacity to imagine, explore, and create realities that are more beautiful and sustainable than anything we've yet achieved. The earth beneath us keeps its secrets still, patient as stone, mysterious as the darkness that conceals them. But in that darkness, in those depths, possibilities continue to exist that could transform everything we think we know about our world and our place within it. The greatest adventure might not require traveling to distant stars, but simply looking down, deeper into the hidden heart of our own planet, where the future of human civilization might already be unfolding in ways we've never dared to dream. The whispers grow stronger when we turn our attention to the ancient maps and forgotten texts that have puzzled historians for centuries, documents that seem to contain knowledge that shouldn't exist, geographical information that predates our supposed discovery of certain lands by thousands of years. These aren't random curiosities gathering dust in forgotten libraries. They're potential evidence of contact between surface civilizations and sources of knowledge that conventional history can't explain. Consider the Piri Reis map, created by an Ottoman admiral in 1513. This remarkable document shows the coastline of Antarctica with startling accuracy, depicting the continent as it would appear without its covering of ice. The problem is obvious. Antarctica wasn't officially discovered until 1820, and we didn't develop the technology to map what lies beneath the ice until the 20th century. Yet somehow, 500 years ago, a Turkish cartographer had access to geographical information that should have been impossible to obtain. The explanation usually offered is that Piri Reis based his map on earlier sources, possibly ancient charts that have since been lost. But this explanation only deepens the mystery. Where did those earlier sources get their information? Who mapped Antarctica when it was ice-free? And how did that knowledge survive through thousands of years to reach a 16th century Ottoman admiral? The accuracy isn't limited to Antarctica. The map shows details of South American coastlines that weren't explored by Europeans until decades after it was created. It depicts islands and geographical features with precision that suggests the original map makers had access to aerial or satellite-level perspective. The mathematical projections used in the map demonstrate understanding of spherical geometry that wasn't supposed to exist in 1513. Similar anomalies appear in other ancient maps and texts. The Oronteus Phineus map of 1531 shows Antarctica as two separate landmasses connected by waterways, which matches what we now know lies beneath the ice. The Mercator map of 1569 depicts Arctic geography with details that wouldn't be confirmed until modern polar exploration. These aren't isolated examples. They're part of a pattern that suggests ancient mapmakers had access to information that conventional history says should have been unavailable. The source of this information becomes even more mysterious when you consider the technical challenges involved. Mapping coastlines accurately requires extensive maritime exploration, sophisticated surveying techniques, and the ability to coordinate information from multiple sources. Mapping what lies beneath ice sheets requires technology we've only developed in recent decades. Yet the information clearly existed in some form, passed down through unknown channels until it reached the mapmakers, whose work we can still examine today. Underground civilizations could provide an explanation for these geographical mysteries. Communities that had been living beneath the Earth's surface for thousands of years would have had both the time and the motivation to develop extensive knowledge of global geography. They would have needed to understand the planet's structure and surface features to establish their own networks and maintain contact between distant underground settlements. Their mapping wouldn't be limited to surface features. Underground civilizations would have developed detailed knowledge of subterranean geography as well. Cave systems, underground rivers, thermal vents, and geological structures that surface civilizations have never explored. This three-dimensional understanding of planetary geography could have given them perspectives on surface features that wouldn't be available to surface-dwelling cartographers. The transmission of this geographical knowledge to surface civilizations could have occurred through carefully managed contact events. Underground emissaries sharing selected information with surface scholars, traders, or explorers. Knowledge passed along through intermediaries who might not have fully understood the source or significance of what they were transmitting. This pattern of knowledge transmission appears in other areas beyond geography. Ancient texts contain astronomical information that predates the supposed development of advanced observational techniques. Mathematical concepts that weren't supposedly discovered until much later periods. Engineering principles that seem beyond the capabilities of their attributed time periods. The Antikythera mechanism, that remarkable ancient Greek device discovered in a shipwreck, demonstrates mechanical engineering and astronomical knowledge that seems centuries ahead of its time. It's an analog computer that could predict the positions of celestial bodies with extraordinary accuracy. The precision of its construction and the sophistication of its design suggest access to accumulated knowledge and manufacturing techniques that don't match our understanding of ancient Greek capabilities. Similar technological anomalies appear in other ancient civilizations. Precision stone cutting that requires tools we can't identify. Metallurgy that produces alloys with properties we struggle to reproduce. Construction techniques that move massive stones with methods we can't reconstruct. Each of these achievements suggests access to knowledge or technologies that don't appear in the conventional historical record. Underground civilizations could explain these technological mysteries as well. Communities that had been developing their sciences and engineering for thousands of years without the interruptions that repeatedly set back surface civilizations. Knowledge accumulated over extended periods and occasionally shared with surface communities through contact events that left traces in historical records but weren't understood for what they really were. The locations where such knowledge transfer might have occurred are revealing, often in cave systems or underground chambers that were considered sacred by ancient peoples, places where surface dwellers went to receive wisdom from mysterious sources that were described in terms that we now interpret as mythological, but which might have been attempts to describe contact with underground civilizations. The oracle at Delphi, that famous source of prophetic wisdom in ancient Greece, operated from a chamber built over geological features that produced unusual vapors and sounds. Modern analysis suggests the site sits over intersecting fault lines that create unique acoustic and chemical conditions. But what if those conditions also facilitated contact with underground communities? What if the oracle's wisdom came not from divine inspiration, but from information provided by beings who lived beneath the earth and had been observing surface civilizations for centuries? Similar patterns appear at sacred sites around the world. Locations where ancient peoples built temples or ceremonial centers over caves, springs, or geological anomalies. Places where wisdom was said to emerge from the depths of the earth. These sites often show evidence of sophisticated acoustic engineering that could facilitate communication with underground chambers. They demonstrate understanding of geological principles that seems advanced for their supposed time periods. The knowledge preserved at these sites often includes information about astronomy, mathematics, engineering, and natural sciences that seems beyond the capabilities of the surface civilizations that supposedly developed it. But if this knowledge came from underground sources, from communities that had been studying these subjects for millennia, the advanced understanding becomes more explainable. The cultural impact of this knowledge transfer can be seen in the myths and legends that developed around these contact points. Stories of gods or spirits who emerged from underground realms to share wisdom with surface dwellers. Accounts of beings who possessed advanced knowledge and technologies, but who remained largely hidden from ordinary view. These stories appear in virtually every culture that had access to significant cave systems or underground spaces. The consistency of these accounts across different cultures and time periods suggests they might be based on real experiences rather than pure imagination. The details often include specific information about underground geography, technologies, and social systems that wouldn't be necessary for purely mythological purposes. They read more like garbled historical accounts than like invented stories. The linguistic evidence adds another dimension to this possibility. Many ancient languages contain words and concepts that seem to describe technologies or phenomena that supposedly didn't exist in their time periods. Terms for artificial lighting, mechanical devices, aerial vehicles, and communication systems that don't match the technological capabilities attributed to those civilizations. These linguistic anomalies could represent attempts to describe encounters with underground technologies using vocabulary that wasn't designed for such purposes. Surface peoples trying to explain devices and capabilities they had observed. but couldn't fully understand, using the closest approximations available in their own languages. The preservation of this knowledge through oral traditions and written texts required sophisticated systems for maintaining and transmitting complex information across generations. The accuracy with which some ancient texts have preserved technical details suggests that the original information was considered extremely important and was carefully guarded against corruption or loss. Underground civilizations would have had strong motivations for sharing certain types of knowledge with surface communities, information that could help surface peoples avoid disasters that might threaten underground settlements as well. Technologies that could improve surface conditions without revealing the full extent of underground capabilities. Knowledge that could guide surface development in directions that would be compatible with underground interests. The selectivity of what knowledge was shared is revealing. The information that reached surface civilizations often focused on astronomy, mathematics, and engineering principles that could improve surface peoples' understanding of natural systems. Less attention was given to military technologies or industrial processes that could be used for destructive purposes. This suggests a careful evaluation of what surface civilizations were ready to handle responsibly. Knowledge shared in forms that could benefit surface development without enabling capabilities that might threaten underground security or environmental stability. The gradual nature of this knowledge transfer explains why technological and scientific advances in surface civilizations often seem to emerge slowly from accumulated wisdom, rather than appearing suddenly as revolutionary breakthroughs. The information was introduced at rates that surface communities could absorb and integrate without social disruption. But the most compelling evidence for underground knowledge transfer might be the gaps in the historical record. Periods when surface civilizations made rapid advances in multiple fields simultaneously, often after apparent contact with mysterious sources of wisdom. Times when technological capabilities seem to leap forward without clear developmental pathways. These breakthrough periods often coincided with increased activity at sacred sites associated with underground chambers or cave systems. Times when surface peoples reported more frequent encounters with beings who possessed advanced knowledge. Periods when ancient texts describe increased communication with entities who lived beneath the earth. The archaeological evidence from these periods often shows signs of outside influence on surface civilizations. New architectural techniques that appear without developmental precedent. Artistic styles that incorporate symbols and motifs that don't have obvious cultural sources. Technologies that seem to require knowledge bases that surface civilizations hadn't developed independently. The decline of some ancient civilizations also follows patterns that suggest loss of contact with underground knowledge sources. Periods when technological capabilities seemed to deteriorate, when complex projects were abandoned, when advanced knowledge was gradually forgotten. As if the external guidance that had supported these civilizations' achievements had been withdrawn. This pattern of knowledge sharing and withdrawal could explain some of the most puzzling aspects of ancient history. Why some civilizations achieved remarkable sophistication and then seemed to lose their capabilities. Why certain technologies appeared in ancient times and then disappeared until being redeveloped in modern periods. Why some knowledge seemed to exist in ancient times, but wasn't preserved through conventional historical channels. The implications extend beyond historical curiosity. If underground civilizations have been sharing knowledge with surface communities for thousands of years, they might continue to do so. Modern technological breakthroughs that seem to come from nowhere might represent continuing contact events. Scientists and inventors who make revolutionary discoveries might be receiving guidance from sources they don't recognize or acknowledge. The locations where modern breakthroughs occur sometimes correlate with areas where ancient knowledge transfer sites were located. Research facilities built near geological features that have been associated with mysterious phenomena for centuries. Universities established in regions where ancient peoples reported contact with underground wisdom sources. the selectivity continues in modern times. The knowledge that becomes available to surface science tends to focus on technologies and discoveries that could benefit human development without enabling destructive capabilities. Advances in clean energy, medical research, and sustainable technologies. Less obvious progress in military applications or industrial processes that could cause environmental damage. This suggests that underground civilizations, if they exist, continue to evaluate surface humanity's readiness for different types of knowledge. They might be gradually sharing information as surface communities demonstrate the wisdom and maturity necessary to handle advanced capabilities responsibly. The ancient maps and texts that started this exploration might therefore be more than historical curiosities. They might be evidence of an ongoing relationship between surface and underground civilizations. A careful process of knowledge sharing that has been occurring for thousands of years and continues today. The geographical information in those ancient maps might represent just one aspect of much more comprehensive knowledge that exists in underground archives. Maps, not just of surface features, but of underground networks, energy systems, and technological installations that span the globe. Information that could revolutionize our understanding of our planet's structure and capabilities. The wisdom preserved in ancient texts might be fragments of much more extensive knowledge bases maintained by underground civilizations. Scientific and technological information accumulated over millennia of uninterrupted development. Social and philosophical insights developed by communities that have maintained stability and cooperation for thousands of years. As we continue to study these ancient sources and compare them with modern discoveries, the patterns become clearer. The evidence for ongoing contact between surface and underground civilizations grows stronger. The possibility that we're not alone on this planet becomes more compelling. The maps spread before us on ancient tables might be invitations to explore not just the surface geography they depict, but the deeper realms of knowledge and possibility that they represent. In their precise lines and impossible accuracies, we might be seeing glimpses of a much larger reality where human civilization extends far beyond the surface communities we know, into depths and possibilities we've only begun to imagine. The greatest discoveries might not require developing new technologies or exploring distant territories, but simply recognizing the knowledge that has been shared with us all along, preserved in documents and traditions that we've dismissed as impossible, when they might actually be roadmaps to understanding the true extent of human civilization on this mysterious planet we call home. The time has come to consider what all of this means for us, right here, right now. As you sit wherever you are, feeling the solid ground beneath you, remember that everything we've explored tonight suggests that solidity might be far more fluid than it appears. The earth under your feet might be alive with hidden activity, pulsing with energies and intelligences we've barely begun to recognize. But perhaps the most profound implication isn't what might exist in the depths below us. Perhaps it's what the possibility itself reveals about human potential. If there are indeed civilizations that have learned to thrive in harmony with the planet's deepest systems, if communities have solved the problems of sustainable energy, social cooperation, and long-term survival, then these achievements prove something remarkable about what we're capable of becoming. The evidence we've examined tonight doesn't demand belief. It simply asks us to remain open to possibilities that challenge our assumptions. Every seismic anomaly, every unexplained gravitational reading, every acoustic signature that sounds too organized to be random geology, they're all invitations to expand our understanding of what might be real. Consider how this changes your relationship with the ground you walk on. Every step you take might be overchambers where entire communities have learned to live in ways we've forgotten or never discovered. Every cave entrance you pass might be connected to networks that span continents. Every strange sound from deep underground might be echoes of activities we've never imagined. The search for hidden civilizations is ultimately a search for hidden possibilities within ourselves. If humans can adapt to the most extreme environments our planet offers, if they can develop technologies that work in harmony with natural systems rather than against them, if they can maintain social structures that promote cooperation over thousands of years, then we have proof that our current limitations aren't permanent features of human nature. They're simply challenges we haven't yet learned to overcome. The mysteries beneath us remind us that our planet still holds secrets capable of transforming everything we think we know. In the depths below, patient as stone and mysterious as the darkness that conceals them, entire worlds of wonder might be waiting. Not in distant galaxies or exotic dimensions, but right here, deeper than we've ever thought to look, in the hidden heart of our own Earth. Whether these civilizations exist in reality or only in the realm of possibility, they serve a vital purpose. They expand our vision of what human communities can achieve. They suggest that the problems facing our surface world aren't insurmountable, but simply challenges that require new approaches, deeper wisdom, and longer-term thinking. As you drift towards sleep tonight, let these possibilities settle gently in your mind. Let them remind you that the world is far more mysterious and wonderful than we often remember. That beneath the familiar surface of daily life, entire realms of possibility continue to exist, waiting for us to develop the wisdom, courage, and imagination necessary to recognize them. The greatest adventure of discovery might not require traveling to distant stars, but simply looking deeper into the world we already inhabit, with eyes open to possibilities we've never dared to consider. In those depths, in those hidden spaces of our own planet, the future of human potential might already be unfolding in ways more beautiful and sustainable than anything we've yet achieved. Sweet dreams, fellow explorers. The Earth keeps its secrets still, but in your dreams, perhaps some of those secrets might reveal themselves to those curious enough to listen.